Have you ever wondered why the sky is blue and not violet or green or any other color? It all comes down to how sunlight interacts with the tiny molecules in Earth's atmosphere. Sunlight looks white, but it's actually made of all the colors of the rainbow, each traveling in waves of different lengths. Blue light waves are shorter and choppier than red or orange waves, and these short waves get scattered in every direction by nitrogen and oxygen molecules high above us. This scattering, called rayleigh scattering, is about 4 times stronger for blue light than for red. But here's a twist. Violet light waves are even shorter and scattered more than blue. So why don't we see a violet sky? It's because our eyes are less sensitive to violet, and the sun emits less violet light to begin with. So blue wins out, painting the sky above us. And there's more. The sky isn't the same blue everywhere. Near the horizon, sunlight travels through more atmosphere, scattering blue light away and mixing colors to create the soft whites and pale blues you see at sunrise or sunset. Fun fact, billions of years ago, Earth's sky wasn't blue at all. It was orange and toxic, filled with gases like methane. Then tiny microbes called cyanobacteria started pumping oxygen into the air, slowly turning the sky blue as we know it today. So next time you look up, remember, the blue sky is a beautiful dance of light waves, molecules, and even ancient life on Earth. Have you ever wondered how a rainbow magically appears after the rain? It's not just sunlight and water droplets. It's a dazzling dance of light bending, reflecting, and splitting inside tiny raindrops. When sunlight hits a raindrop, it slows down and bends as it enters the denser water, a process called refraction. Inside the droplet, the light reflects off the back surface, then bends again as it exits. But here's the magic. That bending splits the sunlight into its 7 colors, from red to violet, because each color bends at a slightly different angle. This splitting is called dispersion. Did you know the angle at which you see a rainbow is always about 42 degrees from the sun? That's why you have to have the sun behind you to see one. And rainbows aren't perfect circles in the sky. We usually see just a half circle because the Earth's surface blocks the rest. There's even more. Sometimes you see a faint second rainbow above the main one with colors reversed. That's caused by light reflecting twice inside the raindrops. This phenomenon is called a double rainbow. And if you're lucky, you might spot supernumerary rainbows, which are delicate pastel bands inside the main arc, caused by light waves interfering like ripples overlapping in a pond. So, next time a rainbow appears, remember, it's a spectacular light show created by physics, geometry, and a little atmospheric magic. Why do leaves change color in autumn? It's not just about the leaves dying. It's a fascinating chemical show triggered by nature's clock. As days get shorter and nights grow cooler, trees get the signal to prepare for winter. During spring and summer, leaves are green because of chlorophyll, a pigment that captures sunlight to make food through photosynthesis. But when daylight fades, trees stop making chlorophyll, and the green fades away. Here's where the magic happens. Hidden pigments in the leaves start to shine. Carotenoids give us bright yellows and oranges, the same pigments found in carrots, and some trees even produce a new pigment called anthocyanin, which paints leaves red and purple. Scientists still debate why trees make anthocyanins, but one idea is they protect leaves from sun damage or help trees recover nutrients before winter. Weather plays a big role too. Sunny days and cool, but not freezing, nights boost the production of these vivid pigments, creating those brilliant fall colors we love. But if it's too warm or rainy, the colors can be duller. And here's a surprising twist. Climate change is shifting the timing and intensity of fall colors because trees rely on total energy they've produced during the year, not just temperature or daylight. So, next time you see a fiery red or golden leaf, remember, it's a complex, beautiful signal of a tree's survival strategy and a glimpse into nature's chemistry and climate.